Welcome to our Precalculus Algebra video where we're going to be solving systems of linear equations. So first of all, let's look at a difference between linear and nonlinear systems. Over here we see an example of a linear system, and you'll notice that all the variables, x, y, and z, they're all raised to only the first power. Okay, that's the first condition that's necessary. The second condition is that any term containing the variables, or any two terms, they're only connected through addition or subtraction. Okay. An example of a nonlinear system over here, first of all, I see y is being squared. That's never the case in a linear system. You never have a variable raised to anything but the first power. Second of all, I can see the y and the z are multiplied together, and that never occurs in a linear system. The terms containing variables are only connected through addition and subtraction. So here we're going to focus on solving linear systems. Okay, let's go ahead and see an example of it now. So let's go ahead and solve this one. I have with a system we take the three equations together, and our goal is to find an x, y, and a z that satisfy all three equations. Now this one's fairly easy in the sense that I can already see that the last equation tells me what z is, right? It says, hey, z is equal to 2. Okay, great. But if z is 2, that means I can plug that value of 2 in right here, because this is the same z, and then I can solve for y. And when you do that, you get, let's see, y take away, well, z is 2. So y minus 2 equals 13. So y has got to be 15. Okay, so we're in good shape, right? We have z, we have y, and now we can use the first equation to get x, because we know y and z. So if you do that, you write out 2x minus y plus z equals negative 1. We're looking for x. So 2x take away, let's see, what was y? Y was 15. What was z? It was 2, so plus 2 is equal to negative 1. I'm just substituting in there. And then I solve that equation for x. 2x minus 13 is equal to negative 1. So 2x has got to be equal to 12. So x is equal to 6. Okay, so our solution is the ordered triple, x, y, and z. So our solution is the ordered triple, x is 6, y is 15, and z is 2. Now if we graph these three, so we'd have to graph this in a coordinate system with three axes. And if we graph them, we're going to find that these are all planes, and they intersect at the point 6, 15, 2. Now, the question is, well, looking at this one was easy because it had a certain form, right? That is, the first equation had 3 variables, the second one only had 2, and the last one had 1. So this equation was missing an x, and this equation was missing both an x and a y. That form we call triangular. And you can see why. It forms a it has a triangular form. And when it's triangular, all you have to do is back substitute, like we did. Back substitute simply means that you substitute the values back into the previous equation like we did and get the other unknowns. Now the question is, are we always going to be dealing with systems that are triangular? And the answer is, of course, no. So our goal is to put them in that triangular form, and we do that using a process what's called Gaussian, G-A-U-S-S-I-A-N, elimination. So Gaussian elimination is what we're going to use to put something into triangular form, and this is named after a famous mathematician, Gauss. So let's go ahead and see what's allowed in Gaussian elimination. So these are operations that we use in Gaussian elimination, and there are 3 of them. The first one is this. You can add a non-zero multiple of one row to another. So in other words, you multiply one row by a non-zero number, and then you add it to another row. And then we replace one of the rows with that new combination, as we're going to see. A second option is this, is that you can multiply an equation simply by a non-zero constant. And then finally, you can interchange the positions of 2 rows. The most useful, the most important is going to be this one, where you add a multiple of one row to another and then replace one of the rows. And then we're going to occasionally use the second and the third. Let's see an example now, solving a system of linear equations using Gaussian elimination. So let's solve x minus y plus 2z is equal to 2. 3x plus y plus 5z is equal to 8. 2x minus y minus 2z is equal to negative 7. Okay, so we're looking to find an ordered triple that satisfies all three of these equations. That's what we mean by solving a system. So the first thing we're going to do, remember, we're trying to get to upper triangular form. Now, upper triangular form, this second equation would not have an x, right? So the first thing we're going to do is we're going to eliminate this term right here, the 3x. And the way we're going to do that is we're going to multiply the top equation by -3, because this will become -3x. And then when I add those together, -3x plus 3x is going to be 0, and that'll be eliminated. Okay, let's go ahead and do that. Now we're going to label what we're going to do as well. So we like to put a little arrow and write this. -3, I'm taking -3 and I'm multiplying it by the first row. That's an R1. And I'm adding that to the second row, R2. This tells me what I'm doing. I'm multiplying the top equation by -3, and I'm adding it to the second row. And I'm going to replace that second row with the result. Okay, so the first equation is going to remain the same after all is said and done. So I put -3 times this row, and then I'm going to add it to that, but you can always keep the original version of that row. So the first equation after we do this is going to be x minus y plus 2z is equal to 2, okay? And then we're going to multiply this by -3 and add it to that. Now when you do so, you're going to get 0 right there, so this is going to, the first term is going to disappear. But then -3, and you have to take the -3 and you have to distribute it, right? It's got to hit every single term and both sides of the equation. So -3 times the -1 here is a +3, and added to the 1 there, because remember we're adding them together, right? So -3 times this is +3, added to that is a 4y, so this is going to become a 4y, and then -3 times 2 is -6, added to 5 is -1, so -z, and then don't forget to do the right hand side as well. -3 times 2 is -6, added to 8, so you're going to replace it with a 2. And the bottom equation was just observing, so right now it's 2x minus y minus 2z is equal to -7. Okay, now we're going to eliminate the x down here, right? Because remember, we're going from that triangular form. So now let's eliminate this one. And the way I'm going to do that is I'm going to multiply this by -2. I'm going to multiply this ruler by -2, by this equation, both sides of this equation by -2, and add it to this. Why -2? Because those are going to add to be 0. Okay, so let's tell our audience what we're doing. We're taking, so an arrow, we're taking -2, and we're multiplying it by row 1, and we're adding it to row 3. Okay, and what's the result? Well, the top equation is at the end of the day going to remain the same, so it's going to be, let's write it as x minus y plus 2z is equal to 2. And the second equation right now is not doing anything, so that's going to be 4y minus z is equal to 2. And the bottom equation, when we do this, it's going to be, let's see, -2 times this added to that is 0. That was the point of doing it. -2 times this is +2. Added to this is a +1y, so this becomes a y. And -2 times 2z is -4z. Added to that is -6z. And then the right-hand side is going to be, let's see, -2 times 2 is -4, and then it's going to become -11. Okay, so far so good. Now we want to, of course, eliminate the y. So we want to eliminate this right here. So what we're going to do is we're going to multiply this bottom row by -4 and add it to the top, to the row above it. Now we're going to put the result of that after that addition. We're going to put that result, we're going to replace the third row with that result. That is, we're going to have this. -4 times R3, and we're going to add that to R2. And the result of this, we're going to, whatever that new row is, we're going to replace R3 with that new row. Okay, so we have this so far. X minus y plus 2z is equal to 2. And then this row at the end of the day is going to stay the same. It's going to remain 4y minus z is equal to 2. Okay, here we go. -4 times this added to that gives 0. So this is going to be 0. -4 times this is 24. Added to that is 23z. And then finally, -4 times this is +44. Added to that is 46. Okay, and then finally, we're almost in, we are in triangular form, right? All we have to do is divide both sides of that bottom equation by 23 to get z by itself. So let's tell our reader what we're doing. We're going to take R3 and we're going to divide it by 23. So we're going to get, top row staying the same, x minus y plus 2z is equal to 2. Second equation, 4y minus z is equal to 2. Last equation, divide both sides by 23, and you get z is equal to 2. Okay, so these are what we call equivalent systems. So you get equivalent systems when you use the operations that are allowed for Gaussian elimination. Now let's write out what we have. Well, we know z is equal to 2. And the next equation, I'm going to solve for y by plugging the z in. That is, I'm going to take the equation 4y minus z is equal to 2, and I'm going to replace z with 2. So 4y minus 2 is equal to 2. So 4y is equal to 4. 4 there. So y is equal to 1. Do the same thing with the top equation. So we have x minus y plus 2z is equal to 2. That's the top equation. You're going to plug in y, and you're going to plug in z that you found a moment ago. X minus 1 plus 2 times, okay, what was z? It was 2 is equal to 2. So x minus 1 plus 4 is equal to 2. X plus 3 is equal to 2. So x is equal to negative 1. So our solution is the ordered triple, negative 1, 1, and positive 2. And you can check this. How can you check it? How can you check that it's really a solution? You take this ordered triple and you plug it into the original. You plug all 3 into here, all 3 into here, and all 3 into there, and it should satisfy each of the equations. Okay, so that's how you solve a linear system using Gaussian elimination. Until next time.